imagine that we could eventually use genome editing to protect people from getting certain forms of dementia that might otherwise, they would succumb to because of their genetics. I think that would be an incredible advance.
Hello and welcome to the GZERO World Podcast. This is where you can find extended versions of my interviews on public television. I'm Ian Bremmer, and today a look at whether gene editing could improve life on Earth or lead us to the same kind of dystopian nightmare outlined in Blade Runner. From curating the perfect crop to eradicating deadly diseases, visiting your local geneticist could soon become as routine as visiting the dentist. I'm talking to scientist Jennifer Doudna, whose work in the field led her to win the 2020 Nobel Prize for Chemistry. Let's get right to it.
The GZERO World Podcast is brought to you by our founding sponsor, First Republic. First Republic, a private bank and wealth management company, places clients' needs first by providing responsive, relevant, and customized solutions. Visit firstrepublic.com to learn more.
Jennifer Doudna, so lovely to see you. Thanks for joining on GZERO World.
Thanks for inviting me, Ian. Great to be here.
So I have to start, of course, congratulations for winning the 2020 Nobel in chemistry. At what point did you first realize that you had discovered something life-changing?
I think I would have to say it came in stages. There was the feeling of anticipation when I started a collaboration with Emmanuel Charpentier back in 2011.
Who won the Nobel with you? Yeah.
Right. As our for our collaborative work, and then there was the exciting results from the lab that came about in over the next few months. And then I think really, with the publication of our work in the summer of 2012, there was a sense that we were on the cusp of a kind of a revolution in biology and in genomics, where it would be possible to use the CRISPR technology to manipulate DNA in such a powerful way that it was going to open the door to lots of opportunities. And that's certainly been true. But that was took a while later, of course, over the next few months to really see how big a revolution it was going to be.
But also, do you feel like you need to be more cautious in what you say, more responsible for what you say? Not just the fact that your platform is bigger, but that the technology that's itself is going to be used in so many ways that will change society.
Well, I think you're right, Ian, that at some level, there's a sense that, there's a lot of excitement, but also caution around genome editing and where it's headed. I am aware that when I give an interview like this one, or things that I might write about, could be interpreted in different ways. So I have to be thoughtful about the way that I'm communicating our science, and not just thinking about how a scientist will think about it, but also how people who are not specialists might interpret it.
Let me ask you a little bit about the science, just for the audience that isn't immersed in CRISPR. Explain for those that have only seen a headline or two what CRISPR is and does.
Well, yeah. So I think it's important to address, like, why do we care? What's exciting here? What's the breakthrough? And in a nutshell, it's a technology that allows scientists to make precise targeted changes to DNA in cells. And the reason that's important is that for the first time, we now have the ability to alter very tiny, all the way up to very large segments of the code of life, the code that makes us who we are, that makes dogs and cats and mice and rice and wheat, and every living thing relies on a DNA code. And because we now have a technology that allows that code to be precisely altered, we can not only study the functions of genes in ways that were previously very, hard, if not impossible to do, but we can also make changes to DNA that will have real world implications in the near future. For example, correcting disease-causing mutations at their source. That's, just a really profound sort of advance in biological research.
Ending blindness, for example.
Yeah.
So, these enormous ailments, disabilities, what is a disability and an ailment, and what is something that's a personal preference, right? How do you think about that?
Well, my own view is that a disability is something that someone considers to be, inhibiting to them in some way. And I've discovered in my conversations over the last decade or so that different people interpret that differently. So I've had people tell me that they don't consider deafness to be a disability for them. For them personally, it's not, because they have found an extraordinary life as a deaf person that they wouldn't have found possible with their hearing present. So, I think for each person at some level that answer might be different. But to me, it's, if there is a condition that is causing suffering in some way, then that is a condition that we should be seeking to mitigate.
That's a pretty expansive view. I could describe being 5'8" as inhibiting. And certainly I know that in many decisions historically, men that are taller tend to do better. Did you intend for me to be able to take it that broadly?
No, but I can see how you might take it there. And, certainly I think an argument could be made. I'm not making it, but one could imagine an argument being made that some physical characteristics are inhibitory to, a person's professional intentions or something like that. Should we be using genome editing to address this? I would say no, but I think we're in a world now where increasingly that kind of choice may become possible. And so it's something that we as a society will have to grapple with.
Are there areas of research and just understanding how the stuff works, not applying it, that you would say, this is too dangerous, scientists shouldn't go there? Or is your view, the scientists are going to discover, they have to discover, progress is the human condition, and then society has to come together and make the rules, let the chips fall where they may?
Well, maybe it's a little of both for me. I think that certainly science is, and we've seen over and over that, the importance of fundamental research to discovery is, can't really be overstated. That being said, are there places where we shouldn't go? And I would say that, certainly things like, working with human embryos, especially with the intent of implanting them to create a pregnancy, that's an area where we need a lot of regulation and caution because there are obvious ethical and societal implications of that kind of work. Same with environmental applications of something like genome editing. If you're going to be releasing insects into the environment that have been edited, and especially if they have the ability to pass their genetic traits on to others in their population that might affect the whole population, I think that's, again, something that needs to be handled with appropriate caution.
Because you're beta testing the ecosystem at that point.
Right. Yeah. The potential to do incredible things and make incredible advances that will be beneficial to our society, but hand in hand with that goes these large risks. So, week by week, I find that, my field is changing. The technology is advancing rapidly. So that's one thing, obviously hard, even as a scientist, to keep up with it, much less if you're a policymaker. And secondly, how do you regulate this?
So look, a lot of policymakers will watch this. If you were able to say, you've got your eye off the ball on this one thing, I'd really like to see this set of regulations in place in the United States, and it's not right now, what would it be?
I don't really have an obvious answer to that. I guess I'm heartened that I think regulation in the U.S. around agricultural uses of genome editing has been actually pretty progressive in the sense that I think there's an appreciation that there's real value in using genome editing in plants that overrides what I think are frankly just misguided concerns about GMO plants. And I've been pleased that the U.S. has been out in front on that issue in many ways. However, on the flip side, I would say that the U.S. has been, kind of behind the times in terms of thinking about human heritable genome editing and how to appropriately regulate that. Right now, for example, it's not legal to use federal funding for any kind of embryo research. And that would, include using CRISPR in embryos. So that just kind of closes off that whole line of research for people in the US unless they have access to private funding.
And does that have the potential to make the Americans less competitive when other countries around the world don't have those restrictions?
It could do that. And it could also create more inequities because it does set up a situation where if people have access to private funding, they can proceed. So, that comes with its own set of risks.
What are the few things that you've seen so far that are you're most excited about in terms of real-time transformations now that matter to human lives, whether it's on the ag side or it's on the dealing with infirmity and disease? Where are we? Give me the Dr. Doudna state of play.
Well, gosh, there's so many exciting advances, but I'll just mention a couple that I think are truly extraordinary. So in addition to the tremendous progress with sickle cell disease and thalassemia, which are well-known genetic blood diseases that have now been effectively cured using CRISPR, and this is work that's been done over the last couple of years, both in the US and in Europe, and has, I think, really shown the world and certainly our field demonstrated that, this is going to be an effective way to cure genetic disease using CRISPR. So that's been very exciting. And then more recently, there was an announcement from another commercial entity that they're using CRISPR now in patients that have a liver disease. And the reason this was so exciting was that it was the first example of a whole body delivery of CRISPR that was able to cure a disease by editing cells that were primarily in one tissue type, in the liver. And so that, again, is an example of, I think, what's coming in the future, where we're going to have increasingly, I think, opportunities to use CRISPR to treat specific diseases that affect our organs, whether it's the brain or the heart or our muscles, our lungs. And that's just, wow. I think it's really, I feel like we're on the cusp of kind of a new world in that regard, where I think we're going to see, a broader impact fastest with CRISPR is the development of plants that are drought tolerant, that is, so important for dealing with the impacts of climate change.
It sounds like you're saying there are these momentous applications that we've already seen, but it sounds like you really believe that the big ones that cause the greatest amount of death, early, premature death in human population, heart disease, cancers across the body, you think this will be meaningful for all of those in the fairly near future?
Well, I'm always cautiously, I'm an optimist, but I'm trying to be appropriately cautious here. But I do think that's coming. I really do. I think, there are some important technological advances that need to happen to make that possible. And the big one there really is what I call delivery. It's how you get the genome editing molecules into the cells where they're needed. That's actually a pretty big challenge. But that being said, a lot of progress is being made, and there's a lot of motivation right now because we know the editing, fundamentally the editing approach works. So there's a lot of motivation to see it applied for diseases that will affect many of us, maybe most of us, including dementias, cardiovascular disease, infectious disease. I think, these are, and cancers, of course. I mean, these are all diseases that, boy, if you had a strategy that was capable of, sort of boosting the immune response to solid tumors, for example, I mean, that would be hugely impactful. I think realistically, however, for the foreseeable future, it will continue to be the case that in most situations, we're going to want to use CRISPR in individuals, not to create heritable changes in the DNA, but really to treat an individual. And I'm anticipating a time when it will be possible, for example, to protect people from diseases that they might otherwise be susceptible to. So, for example, imagine that we could eventually use genome editing to protect people from getting certain forms of dementia that might otherwise, they would succumb to because of their genetics. I think that would be an incredible advance.
Well, because we talk about healthcare, but of course, in reality, what we're spending most of our money on is sick care. It's response to people that already have maladies. And what you're saying is the ability to create these immunities, to build up the ability of human bodies on an individual basis to resist these kinds of diseases. That's what CRISPR is going to be most effective at.
That's right. Exactly.
The reason I went down that path is, of course, in part because of this fellow Dr. He in China, who I know that you know, and created all of this controversy because, he had a delivery system, right, that was supposed to be editing out the ability to, the likelihood of catching HIV. Again, I know that there were all sorts of ethical issues there and other ways that could have been brought about in the case of that child, but he did it. Now, what I thought was interesting is he's in jail now, right?
Yeah.
And so here's one where the Chinese government, seems to have agreed with the international scientific community. This is way beyond the pale.
Yeah, I think that was a very interesting case because when that announcement was first made about using CRISPR in human embryos that were implanted and those babies were actually born, there was, I would say, an international outcry, really. There was kind of a really negative reaction from across the globe. And I think that really did have an impact on the way that work was perceived and pursued in China. And it really shows that, there truly is an international community of scientists who value each other's respect and intellectual contributions. And so when there's an event like that, where there's a negative feedback from that community, it has real impact.
I'm wondering if there are uses of CRISPR that, we actually could get true international cooperation. There are so few areas that we see governments working together to collaborate and cooperate. Is this one that you think that we should be optimistic about?
I don't know if I'm optimistic. I'm actually on a committee right now that's organizing a meeting on genome editing, and we're going to have a specific focus on human genome editing. And I think what's been very interesting with this, and as the topic has kind of continued to be discussed and presented in these international meetings, and reports have been written that have, kind of come out with various kinds of guidelines and criteria around that type of science. It's been very interesting to see how the international community actually has largely coalesced around a set of standards that we all agree are appropriate. Now, does that mean that governments would honor that in the legal system? It's hard to say, but I certainly think that from the perspective of, using the scientific community to regulate, if you will, the kind of science that happens, it's been actually very effective, I would say.
So, this is, I assume, a group of the leading scientists from all over the world that are working on this issue. And what you're telling me is there's actually been a lot more willingness to agree on topics that would be pretty controversial than you would have expected going into these three meetings so far.
Absolutely. Yeah. Well, I'm just guessing here, but I think part of it is that for biological systems, and especially if we're talking about the human body, each of us feels very personally invested in that, right? We've each got a body, and we've got, if we have families, we have loved ones that, might be affected by things that affect our bodies. And so I think there's just a very visceral kind of interaction, a feeling that, we're kind of all in this together, and it's very much a real-time effort. These things are going to affect us, and so we need to pay attention to them. Versus, and here I'm just guessing, I don't know how somebody working in the AI field would think about it, but I'm wondering if it, at least for some people, can feel a bit more removed. They're not quite sure how that impacts them personally. And there's lots of other things to worry about. So maybe it isn't something they need to engage with.
Is there that sense of inevitability that, we're just going to be, quote unquote, playing God? We're going to be creating, adapting life as humanity. And the only question is how long it takes us to get there.
Yes, I would say absolutely. I think that all of us that have been actively, working on these, whether it's these international summits or the World Health Organization report, or, there's lots of venues where people have been involved in crafting the language around how genome editing will be deployed in the future. And I think across the board, at least in those scientific circles, there's the sense that you just said, basically that this will happen. It's a matter of time. And so the important thing to do now is to try to make sure that it happens in the most ethical and responsible fashion.
We know that inequality in the world is growing for lots of reasons, economic reasons, climate-related reasons. As you have the ability to make all of these changes that will affect lifespan, that will affect quality of life, that will affect capabilities in life, certainly parents are going to want the best for their kids. Some of these things are going to be expensive. What do we need to do to minimize or at least reduce the level of disenfranchisement that come from some people having access or earlier access to this kind of life-changing technology?
Well, certainly the first step is just acknowledging what you just said. And I think that's, we have to acknowledge that is one of the really big challenges with, frankly, with any new technology, but certainly with what we're talking about here with CRISPR, because it is a technology that, at least in the early stages, is going to be very expensive. So for example, the therapy that's being based on CRISPR that's being used right now to treat sickle cell patients is costing between $1 and $2 million a patient. And that's clearly just not a price point that will make it affordable and available to everyone globally who can benefit from it. What do we do about that? That's the question I ask myself the most, I would say. I really think about this a lot. And especially being at a public institution, we have a unique opportunity to focus our work around that question, in the sense that when we do the science that we're doing it from the standpoint of, how do I think about making this technology affordable and available to people in the future? And one of the big ones is, we're working on ways that we can deliver the CRISPR molecules much less expensively into patients in the future. And I think that will be one of the ways that we can, help mitigate costs. And then, of course, there's also going to be the scale of this. Right now, this is being used in just a handful of patients for good reasons. It's being still in a testing phase. But eventually we're going to, if it is proven to be safe and effective for people, then I think we're going to want to work as quickly as possible to scale it to a point where that also helps bring down the cost.
Jennifer, thank you so much for joining us on GZERO. I wish you the best with your research. I hope you'll come back and tell us about where it's going.
Thanks so much for inviting me, Ian.
That's it for today's edition of the GZERO World Podcast. Like what you've heard? Come check us out at gzeromedia.com and sign up for our newsletter, Signal.
The GZERO World Podcast is brought to you by our founding sponsor, First Republic. First Republic, a private bank and wealth management company, places clients' needs first by providing responsive, relevant, and customized solutions. Visit firstrepublic.com to learn more.
You're listening to the GZERO World with Ian Bremmer podcast, your weekly geopolitical deep dive into the world's biggest news stories, featuring in-depth conversations with global leaders and newsmakers. To get more of GZERO's insights on global politics every morning, sign up for our free newsletter, GZERO Daily, at gzeromedia.com.